So, picking up where we had left off, we had been working inside of Chapter 6, talking about rational functions. I'd like to kind of continue that discussion now. So to this point, we had talked mostly about simplifying some of these expressions, right, involving radicals or rational exponents. Today we're going to start moving forward here a little bit from there. We'll talk some about solving today. So that's what's on the agenda today. So in this, I'm just going to do some examples. Okay, with that plan, we're not going to do any kind of like general theoretical discussion of this. We're just going to kind of look at some of the different types of solving situations that we can kind of run into and how to approach those situations, and maybe talk through kind of like vaguely what we're doing, but it's basically the same kind of plan that we've used over and over again here. So let's say that we have bless you. Okay. So let's say that we have 3 times the square root of x plus 5 minus 4 equals 8. So here, our basic solving algorithm that we've kind of used over and over again is going to still be the plan. So the idea here is we're going to just kind of use the reverse order of operations. So the first thing we want to do is kind of isolate the radical piece, and then we'll cancel out the radical and kind of finish solving this thing up. So the first thing I'd want to do is add 4 to both sides. So again, I'm just trying to get the radical part all by itself. So the adding 4 to both sides is going to get rid of the subtracting 4. The next thing that I'm going to want to do is divide both sides by 3 to cancel out the times 3. And then I'm going to want to square both sides to cancel out the square root. And now that the square root is gone, I can get at the 5 underneath that was underneath the square root. And that'll be my solution. This is kind of the easiest version of this kind of a problem. Let's see how things change if we instead have a cube root. So still kind of the same initial. So I'm going to start by subtracting 6 from both sides. And then dividing both sides by -4. And then to cancel the cube root, what do I need to do? I use the exponent 3 to both sides. So negative 1 to the third power is still negative 1, just pointing that out, right? Negative 1 times negative 1 times negative 1 is still negative 1. Just to reiterate that I did do something there. That the exponent of 3 just didn't like go away or something. So then we'll subtract the 5 from both sides. And then divide both sides by negative 3. And we're left with x equals 2. Everybody okay there? So again, the fact that it was a cube root this time instead of a square root, did it make the problem really any more difficult for us? No. You just need to make sure that you're using the proper exponent to cancel the radical, but otherwise, it's still basically the same thing. Now, can some weird things happen here? Yeah, sure. So this problem at first glance doesn't look much different than the previous ones we've done so far, right? 4 times the square root of 2x plus 3 plus 6 equals 2. Looks pretty much like the first problem, right? Something different is going to happen here, though. So, looks exactly the same. We should start doing the same things. So we'll start by isolating the radical here. Right? And then if we square both sides, we get 2x plus 3 equals 1. And you're like, oh, what weird thing happened here, right? This looks exactly like the same thing as before. Well, here's the problem. What if I went back and tried to check this? So if I plugged negative 1 in, oops. Oh no, it didn't work. Poop. What's the problem? Did we make a mistake? No, we didn't make a mistake. What we found here is that these solving problems can have extraneous solutions again. So this is an example of an extraneous solution, right? We found an answer doing our solving algorithm. that appeared to be correct. We used the correct work to get it. We didn't make any mistake, but when we go and check it, it still doesn't work. So since that was our only solution and it doesn't actually satisfy, we don't have any solutions left, so we'd write no solution there. I want to point out something to you, that you could have detected that this was a no solution problem well in advance of everything that we did. Specifically, by the time we got to this step, can I take the square root of something and get a negative back? No. The square root is always going to be a non-negative number. So as soon as I see that, I know that this is going to be a no solution problem. Everybody's okay with that? Walter? Uh-huh. By squaring both sides, right. Yep. Now I want to point out something to you guys, though. In the second example we looked at, the one with the cube root, we had a very similar situation here, right? The cube root is equal to a negative. But I didn't bother stopping and checking this answer because this answer works. Why did this one work, but the square root one, that was a problem? Tyler? Yeah, exactly. So that's exactly right. Remember, we can take the cube root of a negative number and we get a negative back. That was okay. So the takeaway here the even root problems, we got to make sure that we're checking because we can get an extraneous solution. The odd roots, though, you don't need to check because you actually can't get an extraneous solution for an odd root. Is that okay with you guys? So again, took kind of the roundabout way to get there, but I wanted to kind of show you as we kind of learned by discovery there a little bit. But that's the takeaway. So make sure that you remember that when we're solving here, when we get to one of these even root problems, like a square root or a fourth root or a sixth root or whatever, you have to make sure that you're checking your answers. But if it's an odd root, a cube root or a fifth root or a seventh root, you don't need to check those. I mean, you can, but you can't get an extraneous solution from it. So if it doesn't check, then you've just made a mistake somewhere. Is that okay with you guys? Okay. That's good. Our next set of examples are going to be, what if we have something like so what I would do is we're still going to kind of treat this the same way. I'm going to start by isolating the radical. In this case, the radical is written as a fractional exponent rather than a radical, but we know they're still kind of the same thing, so we're still going to kind of take the same approach. So I'm going to start just by adding 6 to both sides. And then we'll divide both sides by 4. And then we have to get rid of this exponent of 3 over 2. Right? So what exponent do we need to get rid of that exponent of 3 over 2? So I'm going to do an exponent to both sides. What exponent would I want to use? Okay, I can do a little bit better than squared though, even though. Squared would be okay. I would do the 2/3. Why 2/3? Right, because when we have the exponent of an exponent, they multiply. So you want to use the reciprocal exponent, right? Everybody's okay with that? So that's good. Now, we should try to simplify 8 to the 2/3, right? This looks very much like a problem that we would have done here before break. So I'm going to start just by doing a prime factorization on the 8. So 8 is 2 to the 3rd. And then if I have an exponent of an exponent like this, again, they multiply. So that's really 2 to the 3 over 1 times 2 over 3. And when we multiply exponents, they go straight across. And 6/3 reduces down to 2. And 2 squared is just 4. Everybody's okay there? We need to check that, though. So what it was 4x to the 3 over 2 minus 6 equals 26. So if I typed 4 to the 3 over 2 into my calculator, I would get 8. And then 4 times 8 is 32, and 32 minus 6 is 26. So that is my final answer then. Are we okay there? All right, let's do another like this. What letter am I on? Am I in E, I think? Nobody's going to be too upset if my letters get out of order or something, though, right? If I skip one or repeat one, you guys will fix that in your own notes, I assume. I'm doing my best, guys, but sometimes it takes a minute in between these, and I get confused as how many we've done, and you know, we all make mistakes. Okay. So, same idea, right? We're going to start by isolating the radical piece. In this case, that's the part with the fractional exponent around it. So again, we're at that piece there by itself. So I'll start the same way. We'll add 10 to both sides. And we'll divide both sides by 2. And then what exponent are we going to want to use here? To cancel out the 2/5, we need to use 5/2. That's correct. So that's going to cancel the exponents there on the left side. And then if I did 4 to the 5/2 in my calculator, that's going to be 32. But what I've written here is not correct, or not completely correct, because I've forgotten something. You see how this denominator on the exponent that I did to both sides is an even number? Everybody's okay, so we can see that. In this case specifically, it's a 2, right? An exponent whose denominator is 2 is the same thing as what kind of radical? It's the same as a square root, right? Everybody's agree with that? So I square rooted both sides of this equation, right? On that step. I did some other stuff too, but involved in that, I also square rooted both sides. What do I need to remember when I square root both sides of an equation? I generate a plus or minus. Right? Just like when we solved square or quadratic equations, when we used just the square root, we had to remember the plus or minus. You guys remember that from a couple chapters ago? Same thing's happening here, and you might say, yo, hold the phone, Mr. Kulik. We did that basically that same thing a minute ago, but you didn't worry about it there. Notice on that one, though, the denominator to the exponent that we did to both sides was odd. So there is no plus or minus because I don't get to generate a plus or minus when I cube root both sides of an equation, only if the root is even. So if I do something to both sides of the equation, I generate a plus or minus there only if, when we do that to both sides of the equation, it's an even number rather than an odd number. Okay. So let's go and finish this guy up, the one that we were working on. Hi, fellas.
Sorry about warmer in here than it is in the hallway.
No, it's been very cold. So let's split this guy up into 2 pieces, since there's the plus or minus there. Everybody's good with that plan? And then we'll just solve each one of these separately. Okay, thanks, Matt. So I can subtract 4 from both sides and then divide both sides by deuce. We get 14 for that one. We'll do the same thing over here. Subtract 4 and then divide by 2. And we get negative 18. And if we go back and we look at the original equation here, I want to point out to you that this original equation is an odd root problem. Everybody see that? So do I need to worry about checking an odd root? No. If I do check it, is that okay? Yeah, it's going to work. It's a waste of your time because it should always work, but it's not wrong if you just check them all. You know what I mean? I'm just letting you know that why I'm not checking it. So this one has 2 answers. Everybody's still okay so far? Okay. So there's one more class of problems that I want to talk about. And this is the hardest situation that we'll look at. The one we're about to do. So let's say that we have let's actually, sorry, I need to start with something different first. Shoot. Yeah, it'll be okay. All right, so if we look at this one, what is fundamentally different about this problem than any of the ones that we've looked at so far? I have x's in 2 different locations. You guys see that? So that's our dead giveaway that this is going to be kind of this hardest situation, is where I have x's in multiple locations. Can I subtract x from both sides and subtract the x from the 4x? Is that okay to do? Definitely not. One of them's under a radical, the other is not. So we definitely can't do any subtracting from both sides to put the x's in one place. Everybody's okay with that reasoning? So in order to combine the x's, what I'm going to need to do is get rid of that square root part first. So just like my previous plan had been to isolate the radical part, that would be my first step here. Now the radical is already isolated, right? On the left-hand side, I just have the radical. There's nothing being added or multiplied to it. So there's nothing really to do for that first step. So now I'm going to get rid of the radical by squaring both sides. Now notice here that I can't square the individual terms and have this work. That's not okay. It has to be squaring one side and squaring the other. So when I square the left-hand side, just the square cancels the square root and everything is fine. When I square the right-hand side, though, x plus 2 squared really means x plus 2 times x plus 2, right? So we have to make sure that we're remembering to FOIL there. So I went ahead and foiled that out in my head. Everybody's okay with that? So what I have left now is a quadratic equation, right? To solve a quadratic equation, I have to start first by getting everything onto one side, because I know that I have to have the polynomial equal to 0 in order to solve it. Everybody's still okay? Now, to solve this quadratic equation, we have three methods that we typically use to solve a quadratic equation. We can solve by factoring, we can solve using the quadratic formula, or we can solve directly. In this case, which one of those three is going to be the easiest? I would solve this directly because we have just an x squared and no x. So we can just add 2 to both sides and square root both sides and be done. That's what I would do. You could also use the quadratic formula here, although that's a little bit of an overkill, but it would still work. So again, remember, because I square rooted both sides, I generate a plus or minus here. So I get x equals plus or minus 2. Oops, sorry. Square root 2. Everybody's good? Still okay? All right. Still need to check this, though. Since it's a square root equation. So to do that, I'm going to use my calculator, since it's square root of 2 is a decimal and not a whole number. It doesn't make a lot of sense to write down like a whole number check here. Let's look at it with my calculator. So the left-hand side, I have the square root of 4 times the square root 2 plus 6. So that's the left-hand side. And then I have square root 2 plus 2. So that works. So square root 2 works. Now I'm going to repeat the same thing, except I'm going to use square root negative 2. Or sorry, negative square root 2. There's that one. And there's that one. So they both worked. So there, both of them are a solution. Everybody's okay there? Okay. Let's do another like this, right? These ones can be, I think, are the worst ones. I don't even remember. I'm going to go with G, I guess, is our next letter. I don't know, again, keep it straight. Hold on a second. Okay. Actually, I want that to be 14. My mistake. Okay, now I'm ready to go. Okay, What should I do first here? So first thing I'd want to do is to isolate the radical. So I'm going to subtract 2 from both sides. Right, I want to get that radical piece alone on the left-hand side. And then we'll square both sides to get rid of the radical piece. And I think I miscounted again. That's fine. So remember here, I'm foiling. So I'm not going to write out the pair of parentheses again. I'm just going to make note that I foiled there and write out the foiled result. Is everybody okay there? Yeah, and very easy to forget to do that and just square the individual terms. Have to remember to FOIL. You will not be getting correct answers if you forget to do that. So we're left with this polynomial. So to solve it, we got to get everything onto one side so that it is equal to 0. Yeah, that was one more than I wanted. I'm going to change that to a 13. My apologies, my friends. So we're left with this quadratic equation. To solve this quadratic equation, we can either try factoring, quadratic formula, or solving directly. Which one would be the best one to do in this situation? You cannot solve this one directly because we have both x's and x squareds. So you could use the quadratic formula, or you could try to factor this. Since the leading coefficient is 1, should be easy to factor if it's factorable. That might be a little bit faster than the quadratic formula, although that would still be correct, right? But let's check to see if we can factor it first, since if it does factor, that's going to be a little bit faster than the quadratic formula. Are there two numbers that multiply to give us -4 and then add to give us +3? How about 4 and -1? Right? That multiplies to give us -4 and adds to give us +3. Everybody agree there? So to solve this then, I can just set each of those factors equal to 0. Cool? But I'm not done. What do I still need to remember to do? Gotta check it. Yeah. So we have, what is it? 3x plus 13 plus 2 equals x plus 5, I think, right? So again, let's just use the calculator to do this rather than writing everything out. So we'll use the -4 first. So 3 times -4 plus 13, all under the square root, plus 2. So that one didn't work, right? Notice when I put -4 in for x, I got two different answers. Everybody see that? So let's try the +1. There, that did work, right? Notice I get both of them are the same. So here I have just one solution. And we're going to stop here for today. That feels like enough for one day. So if you look in the content library here, oh shoot. Yes. So in the content library here, you guys should do up through 22. Don't do anything past 22. We're not going to handle those situations in this course. Okay with that, everybody? I'll update that in the interim to reflect that. Yeah. He's just a hungry guy, you know? I get it.